So in the previous video about the RAppArmor package, we showed you how you can use the AAChange profile and the RLimit functions and the setAffinity and setUID and setPriority functions to set restrictions and parameters on the current R process. But then we ended by saying that in most situations you will not be calling these functions directly, but instead you will be calling the eval.secure function. Now, the eval.secure function is a really nice function that wraps everything we've seen so far together into a single function, and it mimics R's built-in eval function, but then has additional parameters to set a RAppArmor profile and hardware restrictions and priority, etc. to a single evaluation, and that turns out to be very powerful. Now, the eval.secure function mimics the regular eval in R, which allows you to evaluate basically an expression, but it has additional arguments which correspond to all of the stuff that we've just been over. So, for example, a profile, which responds to an RAppArmor profile, a user ID, a group ID, the priority, and then there's all these RLimits that you can apply. And the way this works is that eval.secure will take your expression, but it will first create a fork of the current process, and then set any RLimits, user ID, priorities, profiles, and so forth, apply all of the one-way restrictions to the forked process, then evaluate the expression inside this forked process so that it can do no harm, and then take the result of this process and return it to your parent process. So what happens is that there's going to be no side effects on the parent process, on your main R process, even though your expression is evaluated in a secure context. So let's show a little example to see how this works in practice. Let me first just verify that my current process is unconfined, otherwise it will not work. So my current process has no security restrictions. Using the eval.secure function, I can do any evaluation like I would do with the eval function, and it will behave exactly the same as the eval function. So, for example, eval.secure list files root will give me exactly the same thing as, for example, this. However, the eval.secure function has additional parameters. So, for example, I can add a RAppArmor profile to the evaluation. And now it will give me nothing, because what happened here was that eval.secure created a fork, then applied the RAppArmor profile for our base, which is the one we still have here, then evaluated the function, and then returned the result to the parent process. So my parent process is still unconfined. There's no side effects on the current process, but we were able to evaluate a certain expression under a given profile. So in the same way as we use the eval.secure function to apply an RAppArmor profile to a single expression evaluation, we can add hardware limitations to the evaluation of an expression. So let's use the same example as we did before, where we are allocating a large vector of random numbers, let's say to A. Now this will succeed because the only thing we do in this case is applying a RAppArmor security profile which does not set any hardware restrictions. So this is will result in the same output as, for example, we would directly do this. However, suppose we are setting a RLimit AS value to 10 megabyte. Now this will fail just as it did before, because the expression is trying to use more memory than the limit allows. However, the nice thing about using eval.secure is that even though it results in the same error as it did before, we do not have the permanent side effects on the main R session. So the main R session still doesn't have hardware limitations. It was only applied for the duration of evaluating this expression. Another benefit of the fact that the eval.secure function uses a fork to evaluate the expression is that we can easily add a timeout after which the execution will be terminated if it hasn't returned yet. So for example, I have a simple function here to test it, which does nothing else than create a very large matrix and perform a singular value decomposition. And this function will take quite a while to return on most computers. And suppose we want to evaluate this function, but if it hasn't returned after 5 seconds, we want to terminate the process. Now, with eval.secure, we can simply set timeout to 5, and after exactly 5 seconds, the process will be terminated and return an error. Now, note that this is something that's quite hard to do in R. R does have something like a set time limit function, but this function doesn't work while R is executing compiled code from C or Fortran, which is usually the code that actually takes the longest to execute. So we can test it. For example, set time limit to 5 and run the test function, but most likely it will not be terminated after 5 seconds, and it might actually not be terminated for a very long while because the singular value decomposition that we're doing is performed in BLAS, so it will probably not trigger the time limit for quite a while. And even pressing Ctrl C at this point will not interrupt the process. So if they would happen inside a embedded application or a web service, this would be a pretty serious problem. But with eval.secure, we can quite easily set a timeout, and because everything happens in a fork, the parent process stays responsive and can easily be used to terminate the expression. So one thing that might come in hand inside, for example, R-based web services is that we can use the eval.secure function to evaluate an expression under a given username and priority, given that the main process runs as root. So I'm just going to start R with sudo for now to demonstrate this. So you can imagine web servers where users have to log in and they have their own Unix username on the machine, and then you want to evaluate the expression under the given username. So if the web service itself runs as root, you want to switch to another user before evaluating the expression. Well, the current process runs as root, which we can easily see by the getUID function, or we can call the whoami command, which is show root. Now, with eval.secure, we can easily evaluate a certain call under a given username and a given priority. And this will return the result of the expression as if it were evaluated directly with eval, but in fact it was evaluated under a certain username with this priority. And we can easily test that. For example, if instead of rnorm we again call the system whoami command, we do see that the process was executed under username Jeroen. And if we instead of whoami call the get priority command, we do see that the priority during execution was 10, even though the priority of the main process is 0 and the UID of the main process is also still 0. So this could be a foundation for a job scheduler that execute jobs under a given username with a given priority and maybe some other restrictions. So just to wrap up the current video, we saw how we can use the AAChange profile function to apply security restrictions to a running R process, and then we saw how we can use the RLimit functions and the setPriority and setUID functions and so forth to set other restrictions and limitations on the current process. But all of these functions result in permanent limitations on a function, which might not always be what you want. Now, the eval.secure function is incredibly convenient in the sense that it uses a fork to set these restrictions. So this allows you to evaluate a single expression, a single snippet of code under a certain RAppArmor profile with certain hardware restrictions under a certain priority without any of the nasty side effects on your current R session. So this is actually the recommended way of doing things. So that concludes this video. So far we've been using some of the default profiles that ship with the RAppArmor package. Now in the next video we will show you how to go about creating and debugging your own profiles. See you in the next video.